Hello, welcome to the lecture. Uh, in this lecture, we will see about the microwave hybrid circuits. What are the microwave hybrid circuits? So, first of all, we will see the definition, and then we will watch the what is equivalent in detail. So, what is my? We will go with the term that is the microwave hybrid circuit. So there is a term hybrid. Hybrid means it combination of two or more things or devices. So here it is a microwave hybrid circuit. So it, it will be the combination of two or more microwave devices. So yes, but two or more microwave devices, if you will put separate, one is put here, another is put here, so it will not be microwave hybrid circuit. So it will be microwave hybrid circuit only if two or three more devices will be connected in some way to transmit the data from one point to the another point, or to transmit the signal from one point to another. Then this type of devices is known as microwave hybrid circuit. Okay. So what are the examples? So examples are E plenty, H plenty, okay, hybrid T. So what is E-plane? First of all, I will introduce all of you to the E-plane. E-plane T, it is a combination of three waveguides. You can say this, this is arm1, this is R2, and this is arm. So it is a combination of waveguides. Okay, so waveguide is a device, microwave device. So since two or more devices are used and they are connected in some way, so this is microwave hybrid circuit. Again, this H plane, it is again the combination of the waveguide. So one waveguide is this one, and another waveguide is this one, and it is connected like so. Two waveguides are there, two microwave devices are there, and they are connected in some way to transfer the signal from one port to the another port. So this is known as microwave. So again here, see, there are three different waveguide sections. This is the linear waveguide from arm 1 to arm 2, and they, this arm S, okay, and this arm P. So this is a 4-port network, and three different waveguides are connected in some way. So again, it is a microwave hybrid circuit. So let us see one by one what is this circuits and why it is called E plane T, why it is called H plane T, and how we can recognize all these things. Okay, so here okay, here in this case we can see this is a collinear arm, the same waveguide. Okay, so this is a waveguide and this is the another waveguide. Okay, so and we always give the electric field like this. Okay, perpendicular to this horizontal surface. Okay, if this is a horizontal surface, this is a waveguide, so we will give the wave uh, electric field like this, perpendicular to this one. If this is the waveguide, so it will be like this, perpendicular. Okay, so here it is waveguide. Okay, and let us suppose this is a waveguide, and here it is electric field perpendicular to this surface. So if the third arm, okay, if the third arm will be in the direction of E field, okay, as we are watching here, it is E field, okay, and it is perpendicular like this, and this arm is in the direction of this electric field, this one, okay. So this is known as E plane. Now we will see the H plane. What is H plane? So if the electric field is like this, okay, if the electric field is like this, perpendicular to the this horizontal plane. So what will be the value of uh, H field, and in which plane it will vary? Since E field and H field are perpendicular to each other. So if this electric field is like this, so magnetic field will be like this. In so magnetic field will be in this plane, perpendicular to this electric field. Means in the plane of this waveguide. So this is a collinear arm, this one, and this one is the collinear arm. Okay, and this is the third arm. And where is third arm? In the direction of H field. Okay, so this is the direction of E. Okay, and perpendicular to this, in this direction, where it is written H, so it is H in this direction, in horizontal direction. Okay, and this arc is again in the direction of H field. So this is known as H arc, and this device is known as H plane T, because this is looking like a T structure. Okay, it is looking like a T structure. So it is T, but the third arm is in H plane, so it is H. And in the third structure here, this is we are watching that this is the collinear arm. This is the collinear arm, and it is the direction of electric. Okay, this is the direction of electric field. And what is the direction of magnetic field? This one is the direction. So this arm, this one is in the direction of H field. Anna? This is H field, horizontal in horizontal direction. And in this particular direction, this arm is integrated, so it will be the H arm. It will be H arm. And here again, this arm is nothing but in the direction of E plane. In the direction of E plane. Okay, so this is the E arm. Okay. So it is nothing but the combination of this one and this. This is H arm and this is E arm. Here both arms are there. This is H arm. This is okay. That's why it is known as hybrid T. hybrid T. This is one type of T, E plane T, and this is another type of T, that is H plane T, and this is the combination of these two type of T. I told you the meaning of hybrid. Hybrid means two or more combined together, connected in some way. So these are combined together, E plane and H plane T both, and it is connected in this way. So it is known as hybrid. Sometimes it is known as magic tea also. We'll see in the subsequent lectures that why it is known as magic tea. Okay. So moving further to see other types of micro hybrid circuits. So we'll go to the next page, and this is what. Have you seen this structure anywhere? So there are four ports. There are four ports. Port one, port two, port three, and port four. And see, this is uh, the separation between the port 1 and 2 is lambda by 4, and the separation between port 2 and 3 is again lambda by 4, and the separation between port 3 and 4 is again lambda by 4. But see the beauty. The separation between port 1 and 4 is nothing but d lambda by 4. Okay, this is the construction of hybrid ring. This is nothing but hybrid ring. Okay, and it is also known as rat race circuit. It is also known as rat race circuit. Okay, if we will, so this is the rat race curve. We will see it in detail in the subsequent lectures. So it is again micro hybrid circuits because this is waveguide, this is waveguide, this is waveguide, this is the waveguide, and this is bent waveguide. This bent waveguide, and this is the combination of different waveguides and connected in some way. Okay, so this is the reason, that is why it is known as micro hybrid. Again, one more very interesting thing micro hybrid circuit is two hole directional. Two hole directional. What is this? In two hole directional coupler, there are four ports. Port 1, port 2, port 3, and port 2. Okay. So it is just two hole directional coupler. So it is like this. It is the waveguide one onto the another. It is like this. Okay. This is one waveguide and this is another waveguide. Put like this one. So, but the dimension of two waveguides are same. Here it is not same. But what is done is there is two holes here and here in between the walls of the two waveguides, and the separation between two walls is nothing but the separation between two holes is nothing but lambda by 4. What will happen with this one? We'll see. So if there are two possibilities, that wave is traveling like this, wave is traveling like this, wave is traveling like this, and it will go directly to this one, because some of the here it is a hole, so some of the power will go like this, and here also it is a hole, so some of the power will couple like, and it will go like this. What will happen? See, so the path difference between these two paths from here to here and here to here is same. There is no path difference. Path difference is zero. Path length is same. So the waves coming to this port are in same phase. And as we know, the same phase quantities are added together. Okay. And see the beauty of this structure, I will show with the other color. Let us suppose I will stay with this. Let us suppose black. Okay. So coming from here, it will go to here because it is a first hole, and it will go to here also. Some of the power will go directly, and some of the power will couple. And we have seen what will happen when it will go to the port 4, and now we want to see what will happen when it will go to the port 3. So what is the difference in the path length? So it is lambda by 4, and in the returning path it is again lambda by 4. So path difference is lambda by 2. So path difference is lambda by 2. Path difference lambda by 2 matlab phase difference 180 degree. The corresponding phase difference is 180 degree. Means the wave coming through this hole and the second hole are out of phase. Magnitude is same, and they are coming in out of phase. So what will happen? Because the size of hole here and here are same, so coupled power are same in both the directions. So it will get cancelled. Opposite phase cancel each other, and the power coming here is 0. So that is this is the reason, that is why it is known as isolated port. What is it is known as isolated port, and this port 4 is known as coupling port. Okay, and this is through port. So from here it is we are giving the input. This is the input port, and this is the throughput port. So maximum power 99% power is going from here to here, but 1% is getting coupled. Okay, so 1% power we are getting here, and here at this junction we are getting that. Okay, so what is the application of this two hole directional coupler? Okay, microwave powers are very large in kilowatts, in megawatts. So any device is not available to measure the power which has kilowatt power or megawatt power. So this is the reason, that is why we are using this technique. Let us suppose 1 kilowatt power is given from port 1, 1 kilowatt, 1000 watt, and 99% power is coming here. So what will happen? 990 watt will come to this port, and 10 watt will come to this. And now we can measure that. We have a device that can measure the 10 watt. Or if we do not have the device to measure the power of 10 watt, then we can further reduce this size of hole, and 99.9% power will go here. Okay, so 999 watt will go here, and 1 watt will come here. So definitely we can measure. So to measure the power of traveling through a waveguide, directional coupler is used to measure the power. Okay, so that our device is not burned, because 1 kilowatt, 100 kilowatt, 1 megawatt power will go to any device, that will get damaged. So this is the reason we use the alternate solution. We do not measure the power directly. We let us suppose the measured power here it is 2 watt. Measured power it is here it is 2 watt. Means 99% power is going here. So if 99% power is going here, only 1 watt is coming here. Okay, or you can say out of 100 1 watt is here. So in 1 watt it is 1 upon 100. If 200 watt is there, okay, what will happen? It will be 2. Means if we are getting 2 watt here, so 200 watt is the input. So this is the reason, that is why we are using this two hole direction. And this is a circulator. This is a 4-port circulator. So it is again a microwave hybrid circuit. Beauty of this device is, if you will give the input from port 1, it will come to the port, and if we will give to the port 2, it will come to the port 3, and none of uh, there will be no any power at port 4 and 1. And if we are giving the power from port D, it will go to the port 4, and the power at 1 and 2 will be equal to 0. And likewise, if we will give some power from port 4, it will go to the port 1, and the other power at the other ports will be equal to 0. Okay, so this is the beauty of this port circulator. So these are the microwave devices. Okay, these are the microwave devices. Hybrid microwave circuits, you can say. So quickly we will go. This is E-plane T, is the combination of two waveguides. So it is a microwave hybrid circuit. It is again a combination of two waveguides. So it is a microwave hybrid circuit. It is a combination of three waveguides. Again, it is a microwave hybrid circuit, and it is a combination of five waveguides. So it is again hybrid microwave hybrid circuit, and the combination of two waveguides and connected in some way to transfer the power from one port to another port. So this is the two hole directional coupler is again microwave hybrid circuit, and likewise the circulator is also microwave hybrid circuit. I think you must have understood what is microwave hybrid. Okay, so in today's lecture, we will continue further, and we will see the E-plane, one of the that was first plane, that is E-plane, this one. Okay, so we'll see about it in detail. So this is E-plane T. This is also called as series T. Okay, and as I told you that this one, this the third arm must be in the direction of E field given to the thing. Okay, so third arm is in the direction of electric field, so it is a E plane. Now there are two possibilities. What will happen when we will give the input to port 1? What will happen when we will give the port input to port 1? What will happen? It will go like this, it will go like this. Okay, it will go like this, but this arrow is stuck here. Okay, and it will go like this, and there will be no power at port 2 when we are giving the power at port 1. Okay, again, what will happen when we will give the input at port, what will happen? It will come like this. It will come like this. So there are two possibilities. The wave may come like this because this tail will not leave its place, or it head will not leave its place. Okay. If it will come like in this side, then it will not leave this tail, and if it will come in this direction, it will not leave its head. So it will come like this, will come like this, and we will get the input here also, here also. But the what is the difference between two outputs? Magnitude wise both are same, but see the phase. The direction of electric field is upward here, and the direction of electric field is downward here. Means the phase difference between the electric field at port 1 and port 2 when the input is given to port 3 is out of phase. Out of phase. Okay. So this is the region. Now, so here, this is again the case when input is will be given here. We have already discussed this one. So it will come here, it will come here. Okay. So it is like this. So when the waves are fed into the side arm, port 3, okay, this one, the waves appearing, this one, wave appearing at port 1 and 2 are of the collinear arm will be in the opposite phase and in same magnitude. Therefore, S13 equal to S minus 23 out of phase. So 13 and 23. Okay, if we will talk about the S parameter, what will happen? If we are giving the input from here, it is going from here to here, and it is also going from here to here. So this will give the S13 parameter and it will give the S23 parameter. But magnitude wise, both are same. That's no problem. Magnitude wise, both are same. But phase wise, they are out of phase. Means sign is opposite. So S13 is equal to S23, but with the opposite. Okay. Uh, Here I am assuming that all the ports are perfectly matched. But at the end, we will prove that it is not possible. In E-plane T, it is not possible to match all the ports. It's not possible. We will see why it comes like this. But here, for the sake of simplicity, for understanding purpose, we have assumed that all the ports are perfectly matched. S11, S22, and S33 are perfectly matched. Means S11, S22, and S33 are 0. So what will be the S matrix? Like this. And what will be the order of matrix? There are 3 ports. So the order of matrix will be 3 by 2. 3 by 3. In earlier cases, we have seen the 2-port devices where matrix was of 2 by 2. Okay. So this is like this one. From the symmetry property we have. Then symmetry property, all we know that if we will look from port 1 or port 2, it will look very simple. Okay, so this is port 1 and port 2. Anyone will see from here, or anyone other will see from here, the same thing will look like, it will be similar. So it is a symmetrical network. So if it is a symmetrical, by using the symmetric property, okay, so 1 and 2 are symmetrical, 1 and 2 are symmetrical, so S12 and S21 are similar, and S13 and S31 will be same. Also S23 and S32 will be same. Okay, so from the, there are two properties of unitary matrix. There is one property, there is a zero property. In zero property, what is the condition? In zero property, condition is that, okay, if this one like this, there are three columns, so this one and this one will be multiplied, okay, by taking this one as conjugate. Again, this and this may be multiplied taking this one as conjugate, okay, and this may also be multiplied by taking this one as conjugate. We have seen in the previous lecture. So if there is any problem regarding this unitary property, so go to the my YouTube channel, you will get the solution. Okay, so from, there are two properties, there are zero property and there is a unitary property. Okay, so zero property means first column and second columns are multiplied together and it will give to the zero. As we know, S11 and S22 are 0. As we have assumed that port 1, 2 and 3 all ports are matched perfectly, so S11 and S22 are 0. So what will happen? This S31 into S32 conjugate will be equal to 0. And also we know that S31 and S13 are equal. So S, we will put S13 in place of this S31 and it will become S13 into S32 conjugate equal to 0. Let us suppose this is the equation 6. Now come to the another property, that is unitary property. The summation of a square of the magnitude of the first column, okay, S11 ka whole square plus S21 whole square plus S31 magnitude whole square is equal to 1. Again, as we have assumed, S11 is 0. So it is S21 whole square plus S31 whole square is equal to 1. Similarly, for the second column, for the third column, for the second column, S22 will be equal to 0. So remaining term will be like this. And in the third column, S33 will be equal to 0. So remaining term will be like this. So let, this is equation 7, 8 and 9. And equation 4. This is the equation 4. S23 equal to S32. So this is 7 and this is 8. So we are putting the value of S32. So S32 equal to S23. S23. So S23 is there. So what will be the value of S12 का whole square. S12 whole square means 1 minus S23 whole square. This one. S12 का whole square will be equal to this one. And by using the 9th, 8th equation, 7th equation, what will happen? This is S12 equal to S21. So this may be written as S12 also. So S12 का whole square will be equal to 1 minus S31 का whole square, and S31 may also be written as S1 from equation 4. So it will be like S12 का whole square is equal to 1 minus S13 का whole square is equal to 1 minus S23 का whole square. Let this term S13 is 0. So what will happen? From equation 10, from this equation, if we will put this S13 will be equal to 0, so what will be the value of this one? 1 is equal to 1 minus this. So 1 will get cancelled, and S23 will also be equal to 0. Simultaneously, S13 and S23 are 0. Compare equation 9. S13 and S23. If these assumptions are right, then what will happen? This S13 is 0, S23 is 0. So what will happen? This will also be 0. So 0 equal to 1 means equation 9 is wrong. Equation 9 is wrong. Equation means, or equation 9 and equation 10 are contradictory. Equation 10 tells S13 will be equal to 0 and S23 will be equal to 0. And the equation 9 tells the summation of square of the magnitude of these two terms will be equal to 1. So these two are contradictory. If we will put these two values here, it will become 0. And equation 9 tells that the summation of a square of magnitude of these two terms must be equal to 1. So 9 and 10 are contradictory. So we will go further. Okay. And note some point regarding this. This contradiction will be removed only if assumption that all the ports are matched will be proved wrong. This we have made the assumption that all the ports are matched simultaneously. This assumption must be wrong. Okay, so it shows that the diagonal elements of the S matrix of T junction are not all 0 together. Okay, S11, S22 and S33 all will not be 0 simultaneously. And if we will assume that all the ports may be matched perfectly, then the other property will not be valid. So this assumption is wrong. Okay. So further we will see if this will S11, S22 and S33 will not all be equal to 0, then what will be the other option. Okay, I think you must have got some benefits to this video. Thanks for watching. Okay, and come to the next lecture. Okay, for watching the other videos related to microwave engineering subject. Okay, we are um, dealing with the whole microwave subject according to the AKTU syllabus. So AKTU students are will get the more benefit from it. Other students which who want to read for the concept point of view, they must also read, read this or watch this lecture. Okay. So thanks for watching.